Okay, I'll try to make this short and sweet. So, after going through worksheet 3, what we had done, I decided I wanted to kind of see if there was some way we could make like an equation that would work for like all situations. So instead of looking at it like this object from worksheet 3, this car was traveling at a constant 25 meters per second and then slowing down, I said, well, okay, what if it speeds up to 25 meters per second in 4 seconds, and then it slows down from 25 meters per second to 0 meters per second in 4 seconds. So we have some symmetry here. And so while it's speeding up, well, I should say this. We found out that the acceleration during the slowdown was negative 6.25 meters per second. So we know that, which means if I make this true, so again, we can get rid of the red, like, so that's not a thing anymore. Now I'm saying we're going to speed up from 0 to 25 meters per second in 4 seconds, which means that our acceleration now on that side would be a positive 6.25 meters per second squared. And then the slowdown here would still be the negative 6.25 meters per second squared. So I wanted to take a look at that because I wanted to figure out, what if we didn't want to know the whole displacement? What if we wanted to know the displacement just during a single second, 1 second? So we were trying to figure that out. And to do that, we kind of divided it up into a rectangle and then, of course, a little triangle here as well. Now, what we had to know is, how tall is that triangle? Or, I mean, the rectangle. Well, the rectangle is starting at 0 every second. So when you go over 1 second and up, that's 6.25 meters per second, right? Because we said that was the acceleration. So 1 second over is 6.25. Another second over is another 6.25, which is where the 12.5 comes from. So that means this rectangle part at the beginning of the 3rd second here, that rectangle part is 12.5 meters per second tall, which we did here. 12.5 meters per second tall times a second of width. That tells us the area of the rectangle, the tall, skinny rectangle. But then we still have this little triangle here above the rectangle. Now, how tall is that triangle? Well, remember, after another second in time, the velocity goes up another 6.25 meters per second, which makes it the 18.75 that I wrote in here. So that is a height of 6.25 meters per second and a width of 1 second for the area of the triangle. And so that's 1/2 times, again, the base of the triangle is 1 second, and the height of the triangle is 6.25 meters per second. And so that combined, the 15.625 meters, that is the area of the whole thing, that whole trapezoid thing. Now, I had asked, hey, is there some way we can put these numbers into like variable terms? Like, what is 12.5 meters per second to this little 1 second of time interval? Well, that's the VI. That's the beginning velocity at the beginning of the interval. Delta T, of course, the 1 second time interval, that's the delta T. Now for the triangle, we have 1/2, of course. This, the 6.25 meters per second, is how much the velocity changed during that second, times the 1 second time interval. So we have a delta V and then we have a delta T. So this works as an equation all the time. In fact, if we look at this second, this single second in time, how would that work out? Well, the initial velocity now for this second, for the 6th second, It starts at 18.75 meters per second. That's the initial times 1 second. So that is, oh no, this is not going to work. Oh man, this could be a bad situation. So that is, let me get, that's 18.75 meters per second times 1 second plus, now, what about this? 1/2 of the delta V, or well, how much did the velocity change during the second? Well, now it went down 6.25 meters per second. That's a negative change in velocity. So that's plus 1/2 times a negative 6.25 meters per second. Oh my gosh, this is all getting in the way. Oh no. Oh gosh. This needs to move over, and the bell's going to ring here in a minute, and then people are going to be coming in here, and they're going to be knocking on the door because I won't let them in because they're, oh gosh, I don't even know what's going on. Hold on. Oh no. Okay, negative, oh no, negative 6.25 meters per second times 1 second time interval again. And so if you'll notice what's happening here, again, that second cancels that second, and this second cancels this second. And so we get 18.75 meters plus a negative 3.125, which still gives us the 15.625 meters. That's the same as we had before. And again, it's symmetrical, but I hope what you're seeing is this. When the slope was positive here, it was a rectangle plus a triangle, rectangle plus a triangle. Now that it's a negative slope, the rectangle is big because the initial velocity is big, and it's minus a triangle. So now we're subtracting the same size triangle that we were adding over here. So the math works. Whether it's a speed up or a slow down, this works. Now what we did after this, and this is going to be, it's going to look very confusing. What I did was I took, oh gosh, they're going to be trying to get in my room. I'm going to have to end this video soon. What I did is I took the A equals delta V over delta T equation. I solved it for delta V, and I substituted it in place of delta V, which makes this equation. You'll want to write that down. This is what's known as a kinematics equation. That is area under the curve. This is like a rectangle. This is like the triangle. And that's an equation that works all the time. Then, oh boy, here's some other stuff. I guess you could slow this down, and let me get myself out of the way. You could slow this down and then, and pause it and then write all these things down. So this is another kinematics equation, which is I just rearranged this one here. So I just rearranged this one, which is the equation of the go car that we came up with. I rearranged it to look like this. So from here to here to here. Then here, oh gosh, there's people knocking. Can you hear them? Then I took the tumble buggy equation right here, and I rearranged it using velocity, average velocity as VF plus VI over 2. Just a second. Oh my gosh, they're trying to get in here. So I rearranged it and made this equation. So now we have a third one. And then, oh my gosh, this even got more complicated. I solved this equation for delta T, and I substituted it in to this equation, delta T, and now the phone's ringing. I don't even know what's going on. And then we came up with this equation. So there's four equations, and I just posted the assignment on Classroom. So, oh my gosh, this is nuts. So you need all four of those, right? Write those down. It'll help. Okay, I'm done.